Hi, my name is MNguyen, and this is my final presentation on the Laurentide ice sheet for environmental geology with Will Amadon, fall 2020. For my final presentation, I've decided to look at the Laurentide ice sheet. First, I'll give a general introduction. Next, I'll talk about the different ways that we can determine the ages and behavior of glaciers and rocks. Then I'll explain how the Laurentide ice sheet retreated across Maine and New England. And after that, I'll give some examples of how the Laurentide ice sheet shaped the present day landscape of Maine. Finally, I'll give a brief conclusion. So to begin, this ice sheet covered North America and existed during the Pleistocene epoch. The full Laurentide ice sheet existed from 96,000 to 6,000 years ago. At its maximum thickness, it was about 3 kilometers thick and covered 5 million square miles. After the last glacial maximum, the Earth started to warm, causing the Laurentide ice sheet to retreat. The retreat, however, was not consistent. There were oscillations in retreat, or cycles of retreat and advancement. Net retreat of the Laurentide ice sheet occurred around 17,600 to 12,800 years ago. It's important to note that the glacial retreat was asymmetrical, where the southern and western margins retreated much more rapidly than those in the north and especially the east. Figure 1 is a portrayal of the Laurentide ice sheet during the end of the last glacial maximum over present-day North America. You can see that it covered all of New England, much of the northern United States, and almost all of Canada. The dark tan color shows where land used to be. Sea level was about 100 meters lower and exposed much of the east coast. Figure 2 depicts the modeled surface mass balance of the Laurentide ice sheet at various times, with black lines showing the various sectors of the ice sheet. You can see the shrinking of the ice sheet over time. Cosmogenic nuclide dating uses the interactions between cosmic rays and nuclides in glacially transported boulders or glacially eroded bedrock to provide age estimates for rock exposure at the Earth's surface. It tells us how long the rocks have been located at the surface, for example, on a moraine. It can also be used to determine rates of ice sheet thinning and recession, the ages of moraines, and the age of glacially eroded bedrock surfaces. For glaciation, the most common application of cosmogenic nuclide dating is to date the exposure age of glacially transported rocks. Beryllium-10 is the most frequently measured cosmogenic nuclide. We can also indirectly date glacial sediments by looking at the organic materials above and below glacial sediments. Radiocarbon dating provides the age of organic remains that overlie glacial sediments. Figure 3 shows radiocarbon ages in present-day Maine. The different colors of triangles and circles depict the different ages of radiocarbons in thousands of years. Terrestrial samples are shown by triangles, and marine samples are shown by circles. The shaded gray zone depicts the area of post-glacial marine submergence. Generally, you can see that the Laurentide ice sheet retreated slowly from the coast of Maine and worked its way inland. The timing of lateral retreat of the Laurentide ice sheet in New England has been constrained using many radiocarbon ages and cosmogenic nuclide exposure dating in a few locations. It's been found that the Laurentide ice sheet thinned in coastal Maine from 19,000 to 14,600 years ago. Coastal Maine was below sea level due to isostatic depression until 14,000 years ago. At the last glacial maximum, the southeastern margin of the Laurentide ice sheet extended into the Gulf of Maine about 600 kilometers beyond the present coastline and onto Georges Bank. Beryllium-10 ages indicate that retreat was slow until around 20,000 years ago, when Northern Hemisphere summer insolation increased. It took about 7,000 years for the ice margin to retreat to northern New England. Once the ice sheet retreated further inland, relative sea level rapidly fell after due to glacial isostatic adjustment, reaching a relative sea level of negative 60 meters at 12,500 years ago. Simulations indicate that thinning occurred at rates of decimeters to meters per year, anywhere from 15 to 680 centimeters per year. This is broadly comparable to the thinning rates in Greenland and the fastest thinning glaciers in Antarctica between 2002 and 2007. Additionally, vegetation became established rapidly following deglaciation. Figure 4 is a map of New England and southeast Canada showing the maximum extent of the Laurentide ice sheet during the last glacial maximum, which is depicted by the dashed line down here. Also shown are different locations of various moraines created by the Laurentide ice sheet. Additionally, the glacier receded, leaving behind deposits of sand, rock, and soil that gradually formed, creating Long Island and Cape Cod. The slow-moving Laurentide ice sheet changed the main landscape as it scraped across mountains and valleys, eroding rock debris and carrying it for miles. The sand, gravel, and other unconsolidated sediments that cover much of Maine are largely the products of glaciation. Some of these materials were deposited directly from glacial ice as an uneven blanket of stony till. Others washed into the sea or accumulated in meltwater streams and glacial lakes as the ice receded. Glaciation also disrupted earlier drainage patterns and helped create the hundreds of modern ponds and lakes scattered across the state. In Figure 5, you can see the bubbles depicted here and Jordan Pond in Acadia National Park. These hills and valleys were sculpted by glacial erosion. The pond was dammed behind a moraine ridge during retreat of the ice sheet. In Figure 6 is Daggett Rock in Phillips, Maine. This is the largest known glacially transported boulder in Maine. It's about 100 feet long and estimated to weigh 8,000 tons. Figure 7 is an aerial view of glacial cirque basins on Mount Katahdin, seen here and here. The low, sinuous, snow-covered ridge trending across the foreground is the Basin Ponds moraine. Figure 8 depicts granite ledge in Westbrook, showing polished and grooved surface resulting from glacial abrasion. The grooves and shape of the ledge indicate ice flow towards the southeast, so flowing down this way. In conclusion, the Laurentide ice sheet surface dropped rapidly. The ice sheet margin retreated quickly across Maine between about 16,000 and 15,000 years ago. The rate of ice sheet retreat was not consistent across the ice sheet. Western and central portions of the Laurentide ice sheet disappeared faster than the eastern sector. As the ice sheet receded, it sculpted the current-day landscape of Maine. If you would like to see a full list of references and image links, you can follow this QR code here. Thanks for watching.